Good morning, everybody, and welcome to our Innovation Showcase. So the committee wants to understand how the UK supports innovators and what more can be done. And to inform our work, each member of the committee takes turn to select an innovator to share their story before our main evidence session. So Kit Malthouse has brought today's innovator, Jake Davies from Cool Lead. Kit, could you introduce them, please?
Thanks very much, Chair. One of the great joys of being a constituency MP is discovering things about your constituency that you didn't know. And so when I was first invited to go and visit Cool LED in my constituency, I thought, great, we need some ideas for lighting in the sitting room, possibly disco lights for the kids. Little did I know that lurking behind Tesco at Enham Arch in Andover, although they have now moved and expanded, was a cutting-edge, internationally renowned business doing remarkable things with lighting in science. So it's my great pleasure to present to you committee colleagues, Jake Davies, who's the Managing Director of Cool LED.
Thank you for having me. Thanks for inviting me. So as mentioned, Cool LED or Cool LED is based in Andover in Hampshire. We design, manufacture, sell and support cutting-edge LED illumination systems, primarily for fluorescence microscopes for life science research, but also for industrial microscopy systems all over the world. We first introduced the first commercially available LED illumination system for fluorescence microscopy in 2006, following research at the University of Southampton. Fluorescence microscopy is a powerful imaging technique wherein scientists tag specific biological structures within the cells using fluorescent dyes, which must be illuminated then with very specific wavelengths or colours of light so that they can be seen clearly in the image. This is an example which I'll pass around. So you can see in here different parts of the cells become very apparent in the image once they've been dyed and illuminated with very specific lighting under the microscope. Our illumination systems fundamentally consist of LEDs of particular colours mounted onto a substrate with a heat sink on the back to allow them to stay cool, hence the name Cool LED. And then those LEDs are precisely controlled electronically and then optically combined. So here we have, this particular example has 4 such LEDs or channels, 1, 2, 3, 4, and then we have some optics to bring them all together and combine them into one path. This then attaches to the microscope and illuminates the sample within the microscope for imaging. So that's the sort of insides of our products. We provide a family of products that are tuned to specific life science applications, varying in complexity and number of controlled channels. That particular example has 4, with different wavelengths of interest for different fluorescent dyes and applications, and clearly with fitment options to fit all common microscopes. We also design and supply customized illumination systems based on the same technology but for specific OEM customer requirements. For example, automated slide scanning microscope systems and for industrial optical inspection systems. The problem we address. Before Cool LED's LED-based technology, mercury-based bulbs were frequently used for fluorescence microscopy with many drawbacks. They are power hungry, they frequently need replacing, creating both downtime and hazardous mercury waste. They are difficult to control, often leading to photo damage of the tissue sample itself because they're simply too powerful, so you damage your sample before you even image it.
Right, yeah,
not ideal. LEDs offer superior performance, reliability, controllability, energy efficiency, as well as environmental and sustainability benefits. Our market opportunity began with microscopy in life science research labs, and this is now well proven and developed and accepted globally. These traditional manual microscopy techniques are now transitioning into automated systems using robotics to move potentially hundreds of samples and computer vision big data processing, and even AI to perform high number of sample imaging very quickly, with ever more detail faster than ever before. We are also seeing rising demand for automated imaging techniques, which too require precise light delivery onto a sample of interest for quality control or defect detection across many verticals, from food processing to plastics sorting to semiconductor manufacturing. Who uses and benefits from our technology? The end users of our systems are typically laboratory scientists involved in cutting-edge discoveries. For example, we have product on the International Space Station for research looking at how cells grow in 3D. Back down on Earth, world-leading laboratories around the globe use our technology. In the UK, this includes many leading universities and the Francis Crick Institute. Within life science and biomedical science, the research has led to new treatments for critical diseases such as cancer and dementia. Within more industrial settings, automated optical inspection systems can increase the efficiency and quality of various industrial processes. For example, in semiconductor production, meeting the global demand for growth in computing, electronic, and automotive industries, with significant industrial and economic impact. Our approach. We design and build everything in Andover, UK, where we employ around 50 people, but we export over 90% of our sales. We distribute our standard product range globally through resellers, but partner directly for customized solutions. Our approach to product development is to try and really understand the application's needs, often through partnerships, whether academic or industrial, and then deploy our best-in-class engineering team to deliver world-class solutions. We believe in continuous improvement to maintain and further drive our differentiation. We are ambitious, committed, innovative, and supportive of each other, our customers, and our wider environment. I generally consider the UK an excellent location for a niche technology company such as ours with global ambition. We have time zone overlap with practically the whole world, good global transport links, sensible taxation and export policy, and strong supply of university research that may be ripe for commercialization. CoolEd's core technology came from a university research project, and we have since developed another product through a joint project with Strathclyde University. Challenges in the UK. Engineering, in my opinion, does not have the reputation it should have, meaning we don't create or struggle to create the homegrown engineering talent our technology businesses need. It can be challenging and complex to hire foreign talent. We have ever weakening trade deals, first with Brexit and more recently US tariffs, which compose serious challenges to export to major developed markets. What more could be done? UK technology business needs innovation, talent, and ease of global trade. We need strong university research output and strong technological and commercial talent pools to draw on to bring those ideas to successful global commercial deployment, as well as schemes, policies, and incentives to encourage those people to even try. In terms of driving innovation, we must continue to fund cutting-edge research and create the engineers of tomorrow. More kids, especially girls, into STEM, alongside world-class education opportunities, will create the talent needed for the CoolEds of the future. Schemes to encourage entrepreneurship and innovation from this talent pool, such as Entrepreneurs Relief, R&D tax credits, patent box, etc., should be bolstered, not cut. A faster patent application review service would also be helpful. 2 years is not a fast-track service. Alongside clearer guidance of how to access funding from schemes such as Innovate UK to small UK-based SMEs. As UK technology businesses create solutions to global problems, making exporting easier or remaining easy is critical. A free trade deal with the US would certainly help businesses like CoolEd cement their already impressive competitive position in North America. Most importantly, we need to raise the profile of engineering in the UK as an opportunity to create meaningful careers, strong UK employment, and global export potential. It is still impactful, motivating, and important to make stuff in the UK. Thank you very much for your time.
Very good.
Well, thank you so much, Jake. I say, as an engineer, obviously, I very much support your thoughts on the importance and the contribution of engineering. But I've been absolutely fascinating to hear the number of applications of your technology and how you're making and designing it here in the UK and in Kit's constituency. And all I can say to you, Kit, is, walking around your constituency, you can clearly find
exactly.
great scientific innovation. Thank you very much, Jake, for joining us.
Good time.
Order.